some of you might be familiar with this web page if you've used Gmail or one of those services that Google operates that require you to log in before. You've seen this. Does this do? Ooh, awesome. This is our login page, and the way you authenticate to Google is with a password. And this password is sort of like the key to the kingdom, right? The thing that you type in here gives you access. Whoever knows that string, right, has access to your email, to your calendar, to your documents, and so forth. It turns out that these passwords can get into the hands of, bad guys. And there's a variety of different ways this can happen. You could infect yourself with malware. Niels just gave a couple of talks ago a few ideas of how that might happen. You might become the victim of a phishing attack where you involuntarily just give someone a password. Turns out also users reuse passwords for different sites. So users who have a password and use it for Google use the same password at a different site. And some of those sites are better than others at protecting the secrecy of these passwords. Some users have passwords that can be brute forced or guessed. And then there's what we call the password anti-pattern. And for those who are not familiar with this concept, here's an example of it. This is a page on Evite. For those who are not familiar with it, it's actually an awesome site that allows you to schedule events that take place at a certain time, a certain place, and you can invite your friends. And to make it easier for you to schedule such an event, Evite would like to know who your friends are, would like to have access to your address book. So you don't have to retype all the email addresses of all the friends that you want to invite to the party that you're throwing. And so the way they get access to your address book is they ask you for your AOL password, for your Yahoo password, for your Hotmail password, your Gmail password, and the list actually goes on there. I cut it off after a while. And we don't like it for two reasons. One is the reason I already mentioned. Some sites are better than others at actually protecting this information, keeping these password secrets. Not that Evite is one of them, but there might be sites out there that are not very careful with this. The other reason, though, is that if this pattern were to become pervasive, or remains pervasive, I guess I should say, on the internet, then we teach users that it's okay to type their, in this example, Google password for legitimate reasons into other websites. And we don't want that to happen. So if passwords can leak in so many ways, then maybe we should try to get rid of passwords. So what I want you to do for the next 15 minutes or so is do a thought experiment with me where we assume that we bury passwords and we use a different authentication mechanism to authenticate to Google. And let your imagination run wild. Let's assume it's something really secure. I put one example on here. This is like a 3-factor authentication, and one of them is a key that you have in a temper-resistant module that we require all our users to have in their computers. And we also, in addition, when you authenticate to Google, you have to type a little number that you read off one of those key fobs that some manufacturers make, and we require every Google user to have one of those. And you have to also swipe your fingerprint through a fingerprint reader that we also require every user to have. So something like that. Imagine maybe your favorite proposal for a more secure authentication mechanism. And so how are we faring with these sort of password leakage channels if we did something like that? And it turns out it looks actually pretty good, right? If one of the components to our authentication mechanisms is some key that sits in a temper-resistant module that software can't get to, then malware presumably wouldn't be able to extract that key. If I don't have a password anymore that I type into Google to authenticate, then I can't fall for a phishing scam because there's just nothing for me to type there. For a similar reason, if I don't have a password to authenticate to Google, I can't reuse it at a different site. If we move the task of coming up with these keys to some piece of software, from a human to a piece of software. Presumably, the software would be pretty good at generating them in a way that they couldn't be brute forced or guessed. And for the same reason that the reuse of passwords on other sites wouldn't work, the password anti-pattern, where some site asks me, what is your Google password, because I have legitimate reasons to try to access your Google account, excuse me, that wouldn't work either. But it turns out, if we did that, we would make life of our users quite unpleasant. We would break a lot of things. And here's some examples. Let me try and go through through some of these. So up here is a plugin into the Mac Apple Aperture application, which is a photo management application. And there's a plugin that exists for that application that allows users to upload their photos to Picasa Web, which is Google's photo hosting site. And that plugin was not written by Apple. It was not written by Google. It was written by a third party. And it has built into it the assumption that the way you authenticate to Google is with a username and with a password. Similarly, here's an instant messaging client that can talk to a bunch of different websites, one of which is Google, and has built into it the assumption the way I authenticate to Google is with a username with a password. Now, we could maybe take the position and say, oh, those authors were silly to make such an assumption. But sometimes you don't really have a choice. Here's an example of an IMAP client. This is, again, the Mac Mail, I guess, whatever the mail app that you get on the Macintosh by default. It's an IMAP client, has to implement the IMAP protocol. The IMAP protocol has built into it the assumption the way you authenticate to the servers with a username and with a password. So the author here didn't really have much of a choice. Similarly, over here, there's an example of adding an Exchange account to Android. So you can run the protocol there is ActiveSync to get your contact information, calendar information, and so forth. And of course, we would break eVite. It would be much harder to throw parties if we switched our authentication mechanism, because eVite would be so much harder to use. So what are we supposed to do, right? If we do change our authentication mechanism away from passwords? Well, there's a protocol called OAuth that third-party applications can use as an alternative to asking the user for their passwords. And it works something like this. Here's another site that you probably are familiar with. It's called Facebook, and it's a social network. And they try to do something very similar to what eVite was doing. They would like to get access to your address book so they know who your friends are, so the site becomes more useful to you. If you can connect to your friends, Facebook provides a much more interesting experience than if you're there all by yourself. But unlike eVite, who was asking for your username and password, what they do instead is they just put a little button on there. It says, click here to import your Google address book. And then the next thing that happens is you get redirected to Google. You're now at Google, and Google says, Facebook would like to have access to your address book. Is that OK, yes or no? And then when you press OK, then the OAuth protocol makes it so that Facebook ends up with a token that they can use to access your Google account and download your address book. And this works not only for web applications, but also for installed apps. But there was a question in the audience.
Just a quick question. You said that it was asking for access to the Google address book. But I actually didn't see that. It just says it wants access to Google.
Down here, it says Google Contacts. That's what we call the address book. Sorry, the question was, where does it say that it's asking for your address book? So this works for websites, but it also works for installed applications. Here's an example of an application that's an email client on the iPhone. And instead of the app asking you for your Google username and password, it also runs this OAuth protocol, and it pops up a web browser. And so remember, we're still in this thought experiment, right? Google is not asking you for your password. It's doing something different. So that presumably the user does something somewhere between this step and that step that's not shown here, does something different to authenticate to Google. and then says, yes, it's okay for this application that I just installed on my iPhone to have access to my inbox. This is the way the protocol looks. They told us to try to deep dive into some more technical meat this year, but then they told us we only have 20 minutes. So I'm not sure I can go into too much detail here. You might be familiar with the protocol also. The way it works is that the client gets a request. So let's do the example. This is Facebook, this is Google, and this is the user that wants to import the Google address book into Facebook. So Facebook receives a request token. Then the user visits Google and says that they want to approve this delegation. And then Facebook goes and exchanges the request token for an access token. And then they later use that access token to access Google. Now, it turns out the first version of OAuth that was published and that was actually implemented by quite a few companies had a bug in it that allowed a session fixation attack that would allow an attacker, in this case Bob, to impersonate a victim, Alice, to a client. So to come back to the example, so it would be possible for Bob to go to Facebook and say, I want to see my address book, but the information he would be shown would actually be Alice's information. And the reason this worked is because in the original version of the protocol, the client and the server could be confused in associating different identities with the same access token. And part of the story I want to tell here is that how this protocol got fixed. This happened about a year ago. And the fact that it was an open protocol and had so many stakeholders, I think was actually a good thing because a lot of people came together in a very short period of time. I want to say like within a week or so, we had to shut down servers, we had to fix the spec, we had to implement the spec, and we had to bring the servers back up, all within a relatively short time frame. And what now most companies are running is OAuth version 1.0a, which is certain fixes to this flaw. Fast forward 12 months, we're currently working on OAuth version 2.0, which is done within the IETF. And OAuth 2.0, one thing that it tries to do just as a different design is to, instead of having one flow that tries to address different use cases, both the installed apps on your iPhone use case and the web application delegation to a web application use case, it splits it up into different flows that are optimized for each use case. But each flow is simpler than the OAuth 1 flow was. And there's some other differences that, if you're interested, we have time in the Q&A part of it. So to recap this part of the talk, I asked you to do a thought experiment with me where we were assuming that Google drops passwords tomorrow and replaces it with some authentication mechanism that doesn't involve passwords. And what we found was that we would have to move a whole bunch of the internet away from this assumption that the way you authenticate to Google is with the username and password. And we saw a protocol, OAuth, that is designed for that purpose. But one of the points that I wanted to show you is that, there was a little bit of a false start with this OAuth protocol. The very first version of it actually had a pretty major flaw to it. And as we're developing the second version, I invite everybody in this audience to maybe participate in the process of standardizing this new version. If you guys work on protocol verification or something like that, it would be really nice if we had some real results that say, we have proven certain properties of this protocol as it's being standardized. So if we move everybody over from all these third-party applications, from asking for passwords and move them over to OAuth, now users no longer have, and there's no longer an excuse for asking the user to type their, say, Google password into some third-party application. So eVite can replace their page where they ask for username and password with a page that looks more like Facebook's page. But then eVite itself probably still has, I still have a username and password to log into eVite. itself, right? And so all the issues that I brought up in the beginning about passwords apply to that password as well. So one thing that we can do about that is to use this other protocol called OpenID that can help getting rid of passwords on third-party sites also. And you might have heard about this protocol also. It delivers an assertion, an identity assertion, to what we call a relying party. So what happens is that the relying party and the identity provider, so imagine Evite and Google, they exchange some key material in the beginning. And when the user goes to Evite and says, hey, I would like to log in, the user gets redirected to Google. There they do whatever they need to do to authenticate to Google. And then Google redirects them back to Evite with essentially a signed statement in the URL saying this is user number 12345. And then Evite can take that information and log in the user. It turns out that in practice, these relying parties want both. They want OpenID because they don't want to worry about running their own authentication system. It's a hassle, and you can get things wrong, and then your users are exposed. And they want OAuth because they want access to the user's accounts at the service provider where they're coming from. They're providing a service that's so much more useful if they only knew who all the user's friends are, if they only could schedule appointments for the user automatically, and so forth. So we needed to combine these two protocols into one protocol, which we call the OpenID and OAuth hybrid. And it's a little bit of an ugly duckling, in that it literally just puts these two protocols together. It runs them in one flow. But OpenID, for example, is designed to be very ad hoc. There's no pre-arrangement of keys and so forth. They're all being exchanged beforehand. OAuth, on the other hand, requires that you register beforehand and you exchange keys. OpenID has one signature method. OAuth has another signature method. So our OpenID and OAuth hybrid protocol has two different kinds of signature methods for different types of methods for different kinds of messages and so forth. So it's not great. So there's sort of these a problem with the protocol itself. And then we have UI issues that we're also currently dealing with. One of them is what we call the NASCAR problem. And if you haven't heard of that, this is ladygaga.com. And ladygaga.com has a login button. You can log into ladygaga.com. I guess there's a user community or something like that. And they have heard of OpenID. So when you click the login button, you get a page that looks like this. And when I gave these examples, you want to log in with your Google account and so forth. Of course, the same holds for the other service providers on the internet, right? So you can log in with your Facebook account, with your MySpace account, your Google account, your Twitter account, your Yahoo account, your Windows account. Then there's a little arrow here. When you click on that, then the next 6 possible providers slide into view. Or you can have a username and password on the account. So first of all, this doesn't scale. As more providers come online, what this is UI supposed to look like. And second of all, it actually confuses users a hell of a lot. They don't really know what to do when they start a UI like this. So this is an open problem that we're trying to figure out. So to summarize, I talked a little bit about ongoing work in internet identity. We're currently working on OAuth 2, the new version of OAuth. We're pretty sure what it looks like. If you join the discussion groups now, you'll realize that there's sort of some just loose ends that we're trying to tie up at this point. The next version of OpenID is much more open, so to speak. We don't quite know what it'll look like. There are some that call for OpenID vNext to be just a thin layer on top of OAuth 2. Be that as it may, we'll have to end up with some sort of hybrid that gives you both OpenID, which is an identity assertion, and OAuth, which is access to a user's account, all in one protocol. And then I gave you some hint of that there are some UX problems that are also currently unsolved and we're still working on. OK. So 22 minutes into talk. I think this is my last slide. Tell them what you told them. So OAuth eliminates the need for third-party apps to know users' passwords. We went through that. I explained a little bit what OpenID was about. And reminder, if you work on protocol verification or anything like that, please have a look at OAuth 2. Tell us where it's broken or prove to us that it's OK. And so some of the ongoing work that we're currently doing, the new versions of OpenID, OAuth, and some of the UI problems that we're also dealing with. And with that, it's time for questions. Please.
I'm not convinced that OAuth solves the problem. It makes it so that there's not a need for the third party to have to know a user's password. But it seems like it's very easy for a bad guy to pretend that you're entering the password into Facebook or to Google, when in fact they're actually collecting it anyway.
Right. So the question was, couldn't a bad guy, even though OAuth exists and all the good guys are now using OAuth, couldn't a bad guy still ask for your password? Did I?
Can't they pretend to be using OAuth? They make the screen look the same.
Oh, I see. So when I click on the Facebook import my address book from Google button, I said that you're being redirected to Google. What if you're not? What if this isn't really Facebook and they're not really redirecting me to Google, right? Right, we do get this question a lot. And I don't claim that OAuth or OpenID are a solution to the phishing problem. I think the solution to the phishing problem comes from how do I authenticate to my service provider, right? So if it's not really Facebook and I click on the button and they're redirecting me to something that looks like Google, and that page asks me for my password, right? And I say, what do you mean my password? I don't have a password, right? That's, I think, how we should solve the phishing problem. Other questions? Go ahead.
So, getting back to my question about what information you're transmitting, right? So it seems like one scalability problem for this is that you might have different types of information. You may, as we heard, last half hour presentation, right? You might have complicated rules about what you want to share with who, maybe rules that you're not even completely aware of.
Right.
So it seems like unless this authority mechanism has some sort of clearly defined way of kind of structuring what you're giving out to who, right? You're going to run into problems because everybody will just say, "Can I get access to everything?"
Right.
And you'll have to say either yes or no.
So the question is, with this OAuth flow, where you get to authorize delegation to a third party, how do we make it so that the users are really in control what it is that they're authorizing access to? Am I summarizing this correctly? Okay. So that's a very good question. And what we want this authorization page to be, we want it to allow the user to give what we call informed consent, right? They need to understand what it is that they're doing. And it can sometimes be a little overwhelming to read through some of these authorization pages. And this is some of the UI work that we're doing, is to sort of change them every now and then, test them on users, and to make sure that they're really understanding what it is that they're delegating. And it's sort of a complicated question. I agree.
As a follow-up, can you even see what it is that's being transferred from one place to another? If I say I'm giving you access to my address book, can I see what's actually being transferred?
Okay. So a follow-up question is, well, how does the user can the user see what is being transferred? So there is a page under my account at Google where it gives you a summary of who has access to your calendar and so forth. We don't show you exactly which pieces they requested, not at that detail, but you will see that Facebook has access to your calendar. And you can go there and you can revoke it if you want to. That's a question? So the question is, isn't it a benefit if people can have different personas on the internet and log into Lady Gaga with one of them that is not necessarily linked to some of the other stuff that's happening on the internet? And yeah, people should definitely be able to do that. You can do that by, logging into Lady Gaga with your Facebook account, but logging into Evite with your Google account, or having two Google accounts, Or maybe we'll come up with a way to, even within one account, maybe be able to have different personas. And when you see the approval screen, you could say, oh, I want to log in as this persona or that persona or something. I certainly think if users find that useful, we should build it for them. So Facebook tells you can only have one account. So Facebook tells you can only have one account. I can't comment on their account creation policy. I don't know.
Google allows you to have multiple accounts.
But it says in their user policy that you're supposed to have one account.
I'll try to get that fixed.
You can't do it.
We'll get that fixed. The wording is wrong.
Okay, yeah, okay. So at Google, you should be able to create multiple accounts. All right.
It's okay. We grant you the right.
Okay, and I think one more from the back.
So Microsoft had .NET passwords, and that didn't appear to be adopted very well. So what do you think went wrong with their approach that you're actually fixing?
Right. So are you saying, is this the same as Passport?
Right.
Passport? So that's a very good question. It's a question that we also often ponder, because Passport is sort of like a well-known failure in this space, right? They rolled it out. It was the protocol looked very much like something like OpenID, but it really wasn't that successful. And to be honest, I'm not sure that we know the answer to the question. There might be several components to it. One is that it was controlled by one entity, that it only worked with Microsoft. Right? The advantage of the NASCAR UI is that you can pick whose account you want to log in with, right? And that relying parties maybe didn't like to be tied to one service provider. It might be that it was maybe just an idea whose time hadn't come yet. I'm not entirely sure what all the problems were with Passport. We see quite a bit of uptake in terms of traffic and sites that roll it out for OpenID these days. Okay, thank you.